Live. Should I start?
Mhm.
Assalamualaikum, everyone, those who are listening to us, all IEEE members and non-IEEE members. I welcome you all in the seminar with the title Career in Data Science. With us, we have our guest for tonight, who is Dr. Humaira Noor. Before I hand over the session to her, I'll introduce her a little bit. And I'm very pleased to announce that we have Dr. Humaira, who is a PhD in computer vision from NED University and University of Central Florida. She brings with her a 20 years of extensive experience, out of which 7 is exclusively in big data analysis and quality engineering, which she gained as team lead quality analysis at German startup. She is currently a mentor at Career Foundry, helping students and professionals through the data analytics program, ensuring they graduate feeling job ready. Over to you, Dr. Humaira.
Thank you very much, Mubashara. And I thank IEEE for providing me this opportunity. So thanks for introducing me. So quickly a recap, I graduated almost 20 years ago from NED, and right after graduation, I started teaching at NED, and that's why I feel teaching is in my DNA, and I really enjoy teaching and making sharing knowledge with everyone who come into my circle. And I stayed at NED for almost 12 years, during which I did my PhD, master's, and then PhD, part of which was at University of Central Florida, and my majors was in computer vision and machine learning. And after that, I moved to Germany, and here I did my postdoc. And as part of my postdoc in robotic vision, I basically did also a joint project between German and Pakistani universities. Then I moved from academia to the industry, and as you said, last 7 years they were totally related to big data and data analysis and data science. But my heart was always in teaching, and even during my industrial state, I was always looking for opportunities of spreading knowledge. And then, most very recently, I came across Career Foundry, which is actually a German portal or online institute for data science, data analytics, and also they have courses on UX and web development. So that actually, so I'm working as a mentor with them for the past many months, and this has actually brought me back to my original calling, as if like how to share knowledge and how to tell people about what they can learn, what they can do. And Career Foundry is actually very much focusing on people who are changing their careers. So those who have never studied data science or never studied even maths or anything related to programming, they just take it from scratch, and then we make sure that they become job ready. So when IEEE came to me, and I was asked what I would like to share with the students today, I thought maybe introducing people to data science would be a good idea. And if somebody wants to take up this as a career path, how to do that. This would be my focus for the next half an hour, 1 hour. Basically, I will actually start. And can you see my screen here? Can you see my
For
screen?
For now, I cannot.
Okay, I'll stop sharing and I'll start again.
Okay. Even with the introduction, I am very excited for this session and
Thank,
for whatever you are going to tell.
thank you very much. Can you see my screen now?
Can any now I think it's yes. Now we can see it. Yes.
Because I'm not following anything. I won't be able to see anything outside of my presentation because it's in full screen mode. So Mubashira, what maybe we can do is I encourage everyone in the audience to keep on asking questions. And Mubashira, maybe you can keep a note on that, and I'll check back with you if we have any questions. If something comes up in the middle, we can right away answer that. Otherwise, we'll talk about it towards the end. So I highly encourage
Sure.
everyone to
I'll
really
I'll
keep
note
on.
down all the questions, and I'll be putting all the questions for you at the end of the session.
Awesome, that sounds good. So let me actually take you all through a little overview to data and data, everything related to data before we dig into the career and how to start your career in data science. So what you can expect here is basically some basic concepts related to data, more specifically what data pyramid is. And there is a very big question of how important data is, especially when it comes to comparing data with algorithms, and then how we relate data with big data. What when data becomes big data. Then we'll quickly cover the data pipeline. So we'll see what are the steps, and here we'll also see how the different data related careers differentiate from each other, because you may have heard about data analysis, data science, data engineering, quality analysis, business analysis, and there are many terms around this. And you might be wondering what are the differences between these different lines, and we will quickly cover that. We'll touch upon that. I would like to point out what are the things that you need to watch out when you have data related projects, because not everything is super simple, and you might mistakenly, knowingly, not knowingly fall into certain traps. So, what you need to watch out for. And finally, we'll cover the next steps, how to build your profile. So, we'll try to focus more on this step and what are the options, especially now that we have this pandemic all over the world. And you might be thinking that the job market has changed. So we'll see how we can attack the job market with this current portfolio. And Okay. So the basic reason I would like to tell you a little bit about data is, uh, honestly, we don't teach data and data science or data analytics in university. So this is something which, uh, when people come into the market after finishing their undergraduate, this is one of the things that this is one of the options that come to them. So I would quickly go through some basic concepts. So if you are totally new to this field and you have not studied anything about it, you at least know some basics. Okay, so all good from your side, Mubashira. No comments, no questions, no bottlenecks.
I would like to add something over here as academic
Mm-hmm.
from Pakistan universities. Currently, universities have started offering degrees in data science, particularly in data science, BS data science, MS data science,
Mm-hmm.
even BS. I think computer vision as well at some places. But yes, they are relatively new and they are just establishing. So
Right.
that's all from my side right now.
No, thanks for adding that, because yes, now universities are understanding and realizing the importance of data, and more specifically, its scope in the career market. And for example, in my company, in the German startup that I was working in for the past 7 years, it's Clicks. We actually had to take all our newbies through a 2.5, 3 weeks onboarding program where we actually used to teach them all the basic concepts about data and how we use data, because uh, number one, they didn't used to teach that in the university. So now, but not everyone. So if you're a software engineer, you just passed out with a computer science degree, maybe you didn't have many courses on data science. And second is, data science is so broad, because data is such a broad term. What do we mean by data? And every field will have a different definition of data. So, for example, in finance, data is something else. In healthcare, data is something else because that's related to healthcare. So, what does data mean in all different contexts is something which they can never cover. They can only cover general tools and techniques. And just in case you don't know, I'll quickly take you through them. So I'll start with the basic definition of data, and it's the data pyramid that I want to emphasize. So data lies at the basically the bottom or the foundation. We call it that data actually lies at the basement of any pyramid, and it's kind of dark, dull, dirty over there when you talk about data. So people actually now it's a fancy term, data, but a few years ago data was considered as the most meaningless thing, and this is something which we can actually see in the pyramid as well. So the lower you are in the pyramid, the less value add is to that data structure, whatever you have. So data is really just a collection of data points. And when you start restructuring them, when you start formatting them, then you basically convert that data into information. And now you can see here that you start seeing structure into your data. So what was initially a huge jumble of stuff, now it starts making some shape. And when you further refine it, then you are further ahead and you convert the information into knowledge. And knowledge is more like adding context to what you have already. And when you are actually finally able to use that knowledge into your decision making, then that's basically considered as wisdom. And right now, machines don't have wisdom. Basically, you don't have wisdom systems right now. We have databases, information bases, knowledge bases, knowledge systems, but wisdom is kind of very rare. And this is where we would like to go actually. And I'll give you some examples. So let's see, on the left hand side you see some random data. So KAR 8 and 20 and KAR 9 22, IBD 8 16. So there are like some alphabet, some numbers. Now this is in its raw form data. Now, if I start telling you that, okay, the first column that you see here is actually the city code for the cities in Pakistan. So KAR is actually Karachi, IBD is Islamabad. Then you have some information about what we are going through. Let's say the second column, 8, 9, 10, 11, they are actually the dates of the current month. And the 20, 22, 16, 17, they are the temperatures of these dates. So now this exactly the same data that was just a jumble of words, alphabets, and numbers, now it's beginning to make sense that, okay, so this is in the first row, we have the temperature of Karachi on the 8th of October. And in the last row, we have the temperature of Islamabad on the 11th of October. So now this is some information that you have. And what do you do with this information? So then comes in, okay, you know that 20 degrees in Karachi means it's pretty pleasant, it's cool. 10 degrees in Islamabad, it's actually pretty cold. Now, this is some information. If you have converted this information into knowledge, so what do you do if it's pretty cool or pretty cold in a place? It would affect the way you dress up when you go out of your home. It will affect the tasks that you can do when you are out of your home. So let's say at 10 degrees in Islamabad, you may not want to go out on a hike or a stroll in the garden. You might not want to do that. Under 20 degrees, you may say, okay, I'll go do some outdoor course in Karachi, and so on and so forth. You won't be able to do some things when the temperature is 40 degrees, but you'll be able to do that when it's 20 degrees. So the bottom line is, now this table, which was initially a jumble of alphabets, words, and numbers, Now it's basically we have converted it from information to knowledge and to actionable items, that given this data we can actually do something, we can plan something, we can plan our day basically on the basis of this data. And if you add some more columns, if it's going to rain today or not, and how is it going to be with respect to the wind, then you can actually use again this data and information into planning your day and doing decision making. So, and one more example, you see a string of numbers 11102020 on the right hand side, but if I tell you that this is actually what doesn't make sense right now, it would make sense if I can tell you that this is the format of a date and it's today's date basically. So just by providing structure to your data, you are able to make sense out of it. And if I tell you this information that on 11th October 2020, there is going to be a webinar happening at 8 o'clock Pakistan time, 5 p.m. Central European time, you can then use this knowledge to actually take certain actions. You block your time, you free up your day, and then this might actually impact the next steps that you do. For example, study something else or take a career path in that line, and so on and so forth. So this is how you convert your data into uh, knowledge and information and knowledge, so that you can actually make decisions out of it. And that's basically, in a nutshell, what we use data for. So, be it any field, data science, data analytics, data engineering, data business analysis, the core is that you have a set of data points and you want to use those data points into making certain decisions, because those decisions are going to actually help you in improving your business, generating more revenue, getting more users, reducing your costs, and so on and so forth. And how we convert data into those decision making or action plan, that's basically all what data science is about. Tools and techniques that will help you convert this raw data into stuff that you can use for making the right decisions. And then there comes this question: what is better? So if getting more data is better, or having a better algorithm is more important? So when I actually started working on big data, I actually thought that having a better algorithm would make your system stronger. But after working through data for all these years, I realized that actually data in itself is so powerful that sometimes, not sometimes, most of the times, having more data is just better than having a complicated algorithm. Let me give you an example. I'll go back to this. Can you tell me, given all this data, can you tell me what will be the temperature of Lahore tomorrow? We can't tell that. We can't tell that, because no matter how complicated our algorithm is, it can't predict or guess something which it has not seen in the data. But if only we can only add one more row of data where we have today's temperature for Lahore, we will very easily be able to predict the temperature for Lahore for tomorrow. So this is a very crude example of, to show you how adding more data is most of the time better than going for a complicated algorithm. And now think of this in terms of using machine learning for your problem solving. First question comes in: should I use machine learning for solving my problems or not? So this example was exactly the right answer to tell you if machine learning would have given you the right answer or not. It would not have. The second question: we are hearing about deep learning these days, and many people are thinking that maybe if only they can use deep learning algorithms, they would be able to solve many complex problems. Yes, they will be able to solve many complex problems, but most probably they will be able to solve those complex problems even without using deep learning, or even without using machine learning at all. So whenever you want to decide if I want to make something more complicated, you should just think about if adding some more data, collecting more data would be a good option, solution or not. Another very simple example. For example, we all use the search engine Google. Google has a different data for different countries. So the data that they use to give results in Germany is very different from the data that they use for results in Pakistan or in the US. Now, uh, if they want to go to a new country, let's say they want to expand their operations in France, do you think that just by using Germany's data or Pakistan's data or US data, they would be able to cater to the French market in exactly in perfection? The answer is no, because a good algorithm or a complicated algorithm will not compensate for the missing data. So again, more data is going to be a better solution in this case as compared to having a complicated algorithm. And now we come to big data. Uh, how do we differentiate between a normal data and a big data? So I like to define big data as when the size of data in itself becomes a problem, then this is big data. For example, have you ever tried opening a very big file in Excel? Uh, Go on, tell me in the comments. I'll ask Mubashira to go through them. But do you know that in Excel there is a limit of file size that, and beyond that limit you cannot open it. And that file size is 2 to the power 16, so 65,536. If a file has more than those rows, then Excel won't be able to open your file. And big data, in case of big data, the files that you get for processing is hundreds of thousands of rows, even millions of them. And the point that I want to emphasize here is that just opening this file would become a problem if you don't have the right tools. Okay, Notepad might be able to open it, and there are other editors which would be able to open it. But the point here I'm trying to make is that the size of the data itself becomes a part of the problem. So you would need to have special ways to open the file, read and write, communicate. You won't be able to just copy the data on a USB and just hand it over to someone, because that would be too big. You can't just download the data, upload the data on the fly, because the data would be too big. And you won't be, if you want to have some quick access, you won't be able to store it in a regular database, because the latency would be too high. So you'll have to take care of how fast are you able to process the data, how fast are you able to open a file, download a file, read or write from the file. I know that there are sometimes algorithms that would take easily hours and weeks, actually, days to weeks to finish processing, and that's totally fine. So, because, do you hear me properly?
Yeah, I can hear you properly. I think let
Mm-hmm.
me check the
Mm-hmm.
problem.
It seems it's okay now. Meanwhile, I'll keep on speaking. So, basically,
Yeah, you can
mhm.
complete. You can
Okay.
continue.
If something comes up, just let me know. And the thing is that big data is then we define it in three dimensions, in terms of volume, in terms of the speed with which we are getting the data, velocity, and the variety of data that we are getting. So, for example, the data volume grows very fast from megabytes to giga and terabytes and petabytes. In case of normal data, I would say, yeah, normal data, you can store it in tables. Excel and SQL is okay. Then you go beyond that, so databases come in, and then um, uh, and then we go beyond that. So the nice thing or bad thing about database is that you need to have a structure. You need to have, okay, these will be my columns and these will be the parameters that I'll put data in. But in big data, you don't know what data is coming in, and actually it could be social media related data and video and images and text and numbers and so on and so forth. So the type of data that you get is actually hugely varied. And then you comes to how quickly you are getting data. So in normal cases, you could be getting data in batches, in maybe once a month, once a week, once a day, once an hour. But in case of big data, your data becomes near real time. So you are getting data every second, maybe every millisecond. And this basically, the three V's are basically how we differentiate big data from normal data. And I still would reiterate, I like to define big data as when the size of the data in itself becomes a problem. So you need a data engineer just so that he can make sure that you can store the data on a fast disk, retrieve data on a fast disk, and you are hiring people just so that you can handle the data. That's big data. And here is some figures like the data class would be small if it's less than 10 GB and you can manage it with Excel or R. It would fit in your memory, machine's memory. But then big data would be more than 1 TB and you need special distributed databases, and it's stored across millions, across machines, and it could be billions of web clicks, for example. Okay, so now I have been using these terms, engineering, analytics, science, and so on and so forth. So let's see what they are, and we'll then see a little bit more of how these fields are different. This section is important because this would be the place where you may want to decide which field or which direction you want to take. Basically, data analytics versus science. These are the two most overlapping and apparently confusing fields, but they have some differences. Data analytics is more about analysis, as the name says. So, data analysis is more about defining what the problem is, measuring and collecting the data. So, for example, the example that we saw in the beginning, that Karachi date, so city, date, and temperature. You define what's the problem that you are trying to solve. So basically, you want to solve the problem. I want to know, based on the temperature, what tasks I can do in the day. This is your problem. And then you measure what would you need to make this decision. So you decide that you want to take the city name, the date, and the temperature. And then you analyze the data. So between these two steps, come up, do I have all the data? Is it like, am I missing any column or am I missing any data? So for example, let's say for 7th of October, we miss out on getting the data for a specific city. So there might be missing information. How we can do all that cleaning up of data. It's also possible that we are measuring the data all over the world. So in the US side, we are measuring the data in Fahrenheit. In the Pakistan side, we are measuring the temperatures in degrees centigrade. So there is a discrepancy. So we need to clean up and pre-process that aspect. Then you find out that, okay, temperature is okay, but I'm not able to make certain decisions without knowing if it's going to rain or not, or if it has rained or not. So then you improve on your data. So, and then finally you control that, you make certain decisions, and then you see if your decisions are right or not, and then what further tweaking you need to do. So this although it's a full pipeline, this is basically data analytics. So you may notice that you would need some kind of tools here. So data collection and then measurement, that would be more specifically in the beginning, let's say Excel. We sometimes underestimate the power of Excel, but Excel is actually a very important tool because it gives us the first glance of what our data has. And Excel is actually very powerful when it comes to seeing how the different data points are connected to each other. If there is a relation, you can you would laugh at it, but simply sometimes sorting the data in ascending or descending order would give you some important information which would just simply pop out in front of you that you won't see when it's not sorted, or when you can actually do visualizations in Excel. So you can see what different over time, what different values are giving some kind of trend or not. So you can have line charts or bar charts or pie charts. So that would give you different, and visualization makes a huge amount of difference that you can make in certain taking certain decisions. The thing that you would need here is Excel was one, but when your file size would grow a little bit more and you would need some more calculations, then you would need some kind of programming or database-based language. So you may need for data analytics as well SQL, or in a next step Python maybe. But from a data analyst, we are expecting some kind of programming expertise. So we don't want or we don't expect a data analyst to be a hardcore programmer. So if you have not studied programming as your primary undergraduate degree, but you would like to develop this skill even after finishing your undergraduate, you still have a chance. So if you are interested, you can go ahead with a basic Python course, a basic Excel course, which you can do in even less than a month, and you can actually start working on it. We'll cover that in the next few slides, how you would do that, but that's totally possible. One very important thing about data analytics is the visualization that we just spoke about. So Excel has some graphs, some charting mechanisms. Then there are actually tools that would actually give you an idea of dashboards. So making more sophisticated charts. How about I check this aspect from a different angle? How about I merge these two values together and show a different point of view? And very importantly, for the task of data analyst is to understand the requirements and be able to present them to different stakeholders. Your stakeholders could be, most probably, they would be some kind of people in the leadership team who would like to make decisions on the basis of your analysis, which means you need to understand the problem and then explain your solution in very easy, quick, and um, uh, supported by data way. So you are not going to go any hanky-panky kind of solution. Rather, you want to have evidence of your hypothesis supported by the data. Bottom line is data analytics is when you have a little bit of business understanding, or even if not, you have a business problem and you want to look into the data, clean it up, and then find out relations to present it to your stakeholders. Data science is more.
I have a question here from the
Mhm,
audience. Should I
mhm.
ask now or can I keep it for the
Maybe
end?
you can ask now, and I'll see if we should cover it right away or for
Yeah.
later. Yeah.
So for those who are not really good at programming, or those who don't want to go to hardcore programming, as you said,
Mhm.
data analytics is better than. Can we extract this from your talk that data analytics is better for them than data science or data engineering?
True. That's exactly what I mean. Because I'll now go in a little bit more depth for data science and then data engineering. So, but yes, to answer your question, that's exactly true. So, data analysis is more for those people who are who don't want to become hardcore engineer and software developer. They should know how to get their work done using programming. So that's correct. And Data science is more about going deeper into the data. So when there is a lot of missing values and you want to go ahead and apply machine learning to find out solutions. So for example, in my previous company where we built our own search engine, just like Google, we had our own German search engine. So imagine there are certain keywords that uh, the user would type as a query, and the search engine would tell them what's the best URL to go to. So there are many instances where you don't have the query that the user has typed in. How would you answer such a problem? So missing data, but not in the sense of totally missing data. I'm not talking about given German data, find out French results. No, but given a few million or trillion queries for Germany, now a new query comes in which the system has never seen before. How would I find the solution to that? For example, let's say the system has seen best eating places in Munich. So the system knows the answer for this. But a new query comes in which says best pizza parlor in Munich. Now, the system has never seen pizza parlor in Munich, but it has seen eating places in Munich. So how would it know that pizza parlor would actually be classified as a eating place? So this is where machine learning would come in. And then this is where synonymization would come in. So this is now beyond data analytics. So this is something which information is not readily present in data analysis. Rather, we need to have more context, more techniques, dictionary knowledge, and so on and so forth to solve this problem. And this is where science comes in. So this is where data scientists would actually jump in and do all that work. So data scientist is not very um, it's he or she is not very concerned about end-to-end visualization till problem defining. He is not that much concerned about collecting of data, but pre-processing a little bit, of course. But he or she is more about finding meaning into the data, which is not obvious in the first step, and we may need complicated solutions. So this is where machine learning would be applied as well, in addition to normal stuff. Most probably, a data scientist won't be working on Excel because the scope of the problem that he or she is solving is now beyond that. And then comes in engineering. So engineering is something which is the infrastructure. So as I said, you need, when data becomes itself a problem, I need to do something on the data so that it can be accessed very fast by millions, at the speed of millions of queries in a second. Storing that on the hard disk is not at all a solution. Storing that in memory or in cache would be a solution. But I cannot store that in an SQL database. Then what should I do? I should maybe use Cassandra or Kafka. Should I go for an SD based hardware, or should I go for actually some other technology? And now I have, imagine Google, they have millions of users, billions and billions of users, and thousands of machines deployed. And how do I deploy my program such that it's accessible by all over the world? These all questions, how do I do it that my program would run on my machine and your machine and the machine of any other user without any problem? So all these questions, like defining the infrastructure, and how about my system doesn't become it doesn't have a single point of failure. The system should always be available. So what if a machine goes down? How can I bring it up? So you see, it's not at all about processing the data or working on the data. It's now all about how to make sure that your infrastructure is strong enough so that the data scientists and analysts can do their job. So this is basically what a data engineer would do. Um, Yeah, and this is something that
Are we talking? Uh, are we talking about real-time data here as well?
yes,
Like in IoT systems, data is coming from sensors and other devices.
both.
Are we talking about that as well?
Yes, yes, that too. And that makes the system even more complicated. So, for example, yeah, when you talk about IoT and you have a continuous stream of data coming in, what part do you want to cover in the device, what part do you want to send to the cloud, and how do you communicate and yeah, pre-process and post-process and all that stuff. So yes, the application is totally independent. This is all about infrastructure. So engineering is, I would say, this becomes hardcore engineering. Here you would hear the terms like Docker or Kubernetes or Terraforms. This is where you would hear the terms like which kind of database, Cassandra or Kafka, or which kind of language are we talking about? So the front end languages which are very fast, Rust or Golang or um, yeah, languages like these. So this engineering is now a totally different kind of domain where you talk about really the hardware and the software infrastructure. You may actually work with data by focusing wholly solely on visualization. Uh, we cannot ignore the importance of proper presentation and visualization, because now comes in telemetry, like if a machine is down or not, what which device. So for example, in IoT, it's a very nice term that you mentioned here. So when we are talking about IoT, we want to make sure that the device is functioning correctly, and we need to watch out what parameters the device is sending, which means we need to have some kind of visualization that shows all such parameters. And visualization is not only about time or memory or something typed by the user. Rather, it's everything from including all these to the different parameters, how much battery is left. And this is just one example. So consider the domain and all the stuff that you need to visualize because of that. So the bottom line of what I want to say here is that the scope of working with data is really very vast. I simply want to encourage you not to be afraid of the terms related with data, because data could be data analysis, data science, data engineering, data visualization. And also, when it comes to data analytics, if you are focusing more on business side, you can also be a business analyst and not termed as data analyst. So you would be then focusing on the business aspect more than the data aspect, but the job is actually essentially the same. Do we have any questions here?
We actually had the questions about which kind of softwares or tools should we work on when we are dealing with different domains of data, and that
Mhm.
is something which you are pretty much addressing already. That's why
Mhm.
I didn't interrupt you
No
on that.
problem. But I would just repeat, it's again, it's if you are into a programming language, it's Python. To begin
Yeah.
with, yeah, for the beginner level, we start with Excel, and then have a little bit overview to learn SQL and Python and some kind of visualization language or like tool that could be Tableau, for example. Data has a huge amount of applications. So data is like everywhere. It's in healthcare, it's in banks and insurances, it's in telco. We have user data and we have device generated data. We have users' personal data, plus we have the data that the user is generating because of interaction with the product. We have data coming from retail, be it automotive industry, production, or consumer, be it energy. Like you just name the term, so financing or sports or food or like media, or like you just name it and data is everywhere. And here are just some of the companies and the directions where data is being like in use in some form. So I'm sure you can recognize several of these terms. So some are basically using data for analytics. So what does craft has to do with data? So knows craft needs to know where its user base is, in which country, which kind of products are being consumed, and so on. And so, for example, then there are hardware and software vendors. So we just spoke about that there are data engineering that needs to be done. So how will we store that huge amount of data that is being collected? So for example, Microsoft provides its own cloud services, so Microsoft Azure, so that you can actually store the data there and retrieve the data. Then there are insight providers. So you have Google here, so you know what Google does, and you can actually imagine when we talk about data. Then we have research centers and institutes and agencies that use data. We have consultancies like Accenture, Deloitte. They work with data to provide insights to their customers about their customers and their internal processors. And one kind of data companies that we have are data generators. So now with the new trend is that companies are, so the first step, remember we talk about is to collect the data, but how do we collect the data? So so there are companies that actually collect data for you, and they sell your data to others. And yeah, so that's basically, so that's a huge domain where you can actually work when it comes to data. And even in Pakistan, we have a lot of companies that are actually working on data and provide job opportunities there. So searching for job opportunities is actually has become very easy now, especially if you are using the right platforms. I would highly encourage you to build up your profile, your account on LinkedIn, and then start connecting with related people there. So LinkedIn is a very good platform for us to, you just make your account, you polish it, that's something totally different. And then you search for, let's say, data analyst. So you will see that the people with the job title data analyst, you will see the groups that talk about data analysis. You will see all the jobs that are coming with the title data analysis. You will see all news items related to data analysis. And I would encourage you to actually check those out for each of these different job titles, like search for data science, search for data engineering, and then you would see, you can, if you have used LinkedIn, you know that you can actually specify your location, and then it would go tell you the jobs for that title in your location, in your region. And that's a very good way to actually find out the companies that are offering jobs in your region to you. Just a note of caution when we talk about data. As you can see, it's typically so powerful and you can do so much with it. We just need to be sure that when we are working with data, we are taking care of its security. So imagine you are collecting data from your customer. They have their personal information there. You need to make sure that you provide right security. Actually, this is in fact one more aspect where you work on in data related fields. So you basically take care that no unauthorized person can access your data. Second is discrimination. If you if you do not collect your data carefully, you might inadvertently do some kind of discrimination. So if you are collecting the job profiles for in your region, and if you have collected mostly the job profiles of males and less for females, then your all your analysis will actually show that females are less in the field, and of course this might not be a true assumption, because but it would be there, or maybe you are just considering one age group and you are missing out on another age group, and then the data won't be able to handle all the other age groups. So you need to make sure that when you are collecting data, you are not inadvertently falling into the trap of discrimination. And third is privacy. So security was, you need to protect your data from unauthorized access. But privacy means you need to protect your data from your own self, so your users' data from your own self. If you are providing these temperatures information to someone, do you really need to know uh, who you are providing the data to, and the personal information of people related to that data? Sometimes you don't. Even consider, for example, Google. So if Google is providing me, if I type Facebook and Google tells me to go to facebook.com, does Google need to know how old I am? Like, this is my personal information, or what else have I been searching for? So no, the answer is no. If I ask Google to tell me what Facebook is, how can I go to Facebook? It should just take me to Facebook. And you might also want to take care of users' privacy in such cases. Building your profile. So I copied this slide and the next one or two slides from a webinar which I have mentioned here, Data Science Dream Job Webinar. So these are not my slides, but I have copied. And I'm placing them here to highlight the fact that when you would go and search for skills in the job description, there would be huge amount of skills mentioned there. But what you need to know to get hired is a very limited amount. And how do you handle that? The basic is that you need to know the core data science skills. So you need to know how to complete a big data science project or a basic data science project end to end. And sometimes you don't even need hi-fi maths or hi-fi statistics for that. Even as I said, sometimes SQL is good enough. If you can understand the problem, do some processing, visualize and present the data in a right way. So first thing is that you need to do some and how to handle an end-to-end software or project to the end. For example, if we are going for machine learning, there are some algorithms which do not need complicated machine learning at all. You just need to know, let's say, 10 algorithms, 5 algorithms on how data science works. But once you have these basics, you take one thing which you are good at, and that becomes your data science superpower. So this is something that you need to ask yourself: what I have done, what I like to do, what I'm good at. Are you a software engineer? If you are a software engineer, software engineering is your superpower. If you are good in visualization and presenting results, then visualization is your superpower. If you are a consultant, if you have good domain knowledge on certain domain, then business analysis is your superpower. So you get what I mean. So a data scientist has to know. So you have to be a jack of all trades and master of one. So that is something that you can then highlight in your portfolio. So you know end to end how data science works, but then you show some nice dashboard or whatever your superpower is, to show that you are really good at this one thing, and you can add value and bring value using this. But it's not like only this. You know what you are talking about, what you yeah, how the other parts of the puzzle fits in. And if you want to get started, one course that I can strongly recommend you is mining of massive data sets. It's a course from Stanford University, and it's free of cost. You can simply search for mining massive data sets, or you can just go to mmds.org, or you can go to Coursera, or you can go to Stanford University website. You may want to note this name, The Mining of Massive Data Sets by Murray, Anand, and Jeff. And these are the three professors who teach this course, and they have also written a book using which they teach this course. If you can't find it, I have all the slides and video lectures in the book. Just write to me and I can provide that to you. But this book takes you, and this course actually takes you from the basis of data, and really a very hands-on how to actually solve big data problems. So if you want to go further, my second recommendation, actually the third recommendation, is to go for this course. The first one was go to LinkedIn and check out how check out these titles. The second one is build your profile in by studying the basics, and the third is you can go through this book. So towards the end, I would only say that data is the new oil, and data is everywhere. Even in this current situation, the job market for data is totally open. There are so many jobs out there. In fact, many jobs related to data are being outsourced because the companies don't want to hire full-time data people, and they are happy with having other companies do their data related work. So it's not like hiring for data people is stopping. It's just shifting from companies to other kinds of companies. We need to be careful about what data we are talking about. If you give garbage into the system, you will get garbage out of the system. And this makes the choice for data, the right data points, very important. This gives this opens the room for cleaning up of data, pre-processing, and all the stuff that a data analyst has to do to make sure that the data that they are using, the system is using, is really valuable. We also saw that data is one very powerful aspect of the picture, the other one being algorithm. I am not undermining the importance of algorithm, but sometimes you need to pick if you want more data or a better algorithm. We saw big data, the 3 V's of big data, and we also saw the multiple dimensions of data, how you can go into data analysis, data science, data engineering, visualization, business analysis, and so on and so forth. Job search, you can go to LinkedIn to do that. If you need any help in making your profile, getting help on how to build your CV, how to build your LinkedIn profile, feel free to reach out to me. I'll be very happy to help. And this is a place where I really want to mention that job market has changed a lot because of this pandemic. Now people are very open to allow remote work and especially freelancing work. So if you want to explore this field further, you can open up your accounts on portals like Upwork or Fiverr, and or any other platform which is available in your region, where you can check out freelancing jobs. And this is also one way to actually get into the market. And again, if you need any help with that, if you want to gain some exposure by working on some project, do let me know. I am on Upwork as well, and I get projects from time to time. And if you are interested, I can maybe help you in finding a project for you, or maybe we can work together. So just let me know if you are interested. And the grass is actually greener on both sides, and there is actually hope and scope basically for data. We talked about data mining, mining massive data sets course. And if you need any information about that, feel free to write to me. And finally, if this is Dr. Humera, and if you really would like to get in touch for more questions, feel free to get in touch. I hope you found this session useful. And as I said, feel free to connect to me. My email ID is humera.noor@gmail. And I'm also on LinkedIn. Feel free to connect to me. And if we have any more questions, I'm very happy to take them now. Thank you.
First of all, I would like to thank you a lot, Dr. Humera. It was very, very comprehensive. Basically, for a person who was a newbie to a person who has some sort of background, it was really amazing. Thank you so much.
Most
Um,
welcome.
uh, Most of the questions that I'm getting are related to skills want to become machine learning engineer also. Okay, so there is one question from Muhammad Irfan that says, what skills must he have in order to become machine learning engineer?
Machine learning engineering requires some good knowledge to begin with, theoretical knowledge of machine learning tools, which could be, for example, artificial neural networks and support vector machines, some classification algorithms, etc. The book that I mentioned is very, very good for that, and I am sharing. Just give me a second. I'm sharing a course. Actually, I can post something to you, Mubashara, right? Andrew NG machine learning course. So there is a
Yeah,
machine.
sure.
Yep. So there is a machine learning course. So I have just posted this link to you, this name to you, Andrew NG. His course on machine
And
learning.
you, and
Yeah, Andrew, the W
yeah,
is missing here. So check
yeah,
this
yeah,
out. This one would take you from the basics to really what you need in machine learning. So this is the guy who actually developed uh, deep learning, and I've heard that his course is
yeah.
amazing.
Yeah.
Now,
So
what?
even before, although Dr. Humera is the most expert here, I just want to add a few things that in order to develop expertise in machine learning, you need to have very strong knowledge of linear algebra and statistics as well. That students sometimes lack over here. Being academic, I come across these kind of things that students do want to learn the math behind the engineering algorithms, and they want to be engineers, like
Exactly.
machine learning engineers. So that is also a thing that if you are taking, she recommended you NUNG, and if you are taking NUNG course, that means you have to be very good with mathematics as well.
Actually, this course
So
covers
that's just my
linear.
2 cents on that.
I totally agree, and this course
Yeah,
actually starts with the linear algebra as well. And if you talk
yeah,
about
yeah,
and we sometimes basically ignore the importance of basic maths and theory. If you would like,
yeah,
yeah, if you want a straightforward answer, which machine learning library I should use, if you are a Python expert, or if you want to use Python, then maybe go for TensorFlow uh, or Keras. So that would actually help you in developing your machine learning hands-on experience. But I would strongly recommend, as Mubashira said, improve your linear algebra skills. Go for a machine learning course, and this is actually free, available free of cost, and you can check this out. Mm-hmm.
We have one more question that says, because I told you there are certain universities that are now offering degree solely in data science as well. So the
Mm-hmm.
question is that what should be preferred, CS on undergraduate level or data science? Like BS in CS or BS in DS is more preferred? That's the question from.
Okay, and at undergraduate level, I would recommend to be a little bit more general. You can be more specific later on in your career. So that's why undergraduate is typically broader, and then you go for masters. So if you ask for a one-liner answer, I would go for data science before going. Sorry, I would go for computer science than towards data science, because in computer science they would teach you how computers work and like basics of data structures and algorithms and compilers and how memories are working and a little bit of computer architecture. And having all this know-how would actually help you more when you develop your data science skills.
Um, I have actually a question because since you have been in academia and then you switched to industry as well,
Mhm.
um, what would you like to add that what I understand is that data science has everything for almost everyone. It's very interdisciplinary. It's not
Mhm.
really compartmentalized.
True.
Even if you are from biology, you can be a biomedical engineer and work somehow on machine learning or data, somewhat.
Yeah.
So, what we do usually in Pakistan is that we segregate every department very discreetly. So, would you like to add something on it? Should we start changing it at academia or in universities primarily? Because that's something
Definitely.
I endorse a lot. But obviously,
No, you are right. But as far as I remember, but I was at NAD like 20 years ago, and there our first year was totally very generic. So, in being a computer engineer, we were actually studying civil engineering and mechanical engineering courses, so that in the next year we have the option to decide if we want to switch departments. Of course, in a junior level, if you need to have a base, and that base can become strong only if you have a flavor of things that you are not going to be a major in. So, yeah, I still remember that we had a course on physics and a chemistry course and some maths, and there was only two courses on computers. So, ITC, the introduction to computers, and programming languages. So, with very basic programming. So, yes, I do agree that some courses should be common, and then you build your basis on that. And
some universities in Lahore are also doing that, but they are very few. There are very few who actually introduce interdisciplinary courses at very start. Um, but thank you so much for the discussion on it. There is one more thing that I see lacking in the market over here in Lahore. That is recently it happened that if you have to switch the field, since you talked about switching the field initially, so it can be a better opportunity to start with some sort of internship in that area, for example data science or machine learning or anything. Usually, when I see, because I do some career counseling myself as well. So whenever I see internships, they are mostly based in Karachi. In fact, there are a lot of people offering internships in data science or machine learning in Karachi. But can you recommend some of them, or do you know some of them which are in Lahore as well that are offering? Because for internship, moving or relocating is obviously
Mhm.
not a good idea for everyone.
That's true, and I would say now the options of working from like remotely online is becoming kind of a second nature to many companies, and then you won't be even restricted to being in Lahore actually. So you can get projects from let's say companies which are offering freelancing options, because even companies in Europe and the US, they are looking for solutions, and they just need to get their stuff done. And if somebody from Pakistan is able to do it, they are very happy to hire them. So in this case, I would actually recommend taking up projects from online portals. So go check out Upwork, Fiverr. They have so many options there.
Sure. We have one more question from Suhaira Fatma, that she says that can a BS biotechnology student shift in data science somehow?
Yes. So anyone can shift from anywhere to data science. So if you have, uh, because as we just saw, there are so many ways that you can focus on in data science. There would be, you need to know the whole pipeline a little bit, and then you can be a major. So you can look for companies who have, and you can, for example, go into the business domain analysis for bio-related companies. So if biotechnology means creating biomedical equipment, you can go and offer your services in that, and actually you would have you would be a very nice add-on because you'll have background in biotechnology and then a little bit of data science. So that would be you can be the specialist there. In this case, I would recommend, if you don't want to go too deep into programming, which of course is not always the only option, you can then focus on the business domain and then a little bit of programming. So yes.
That's very nice.
Mhm.
Another student asked that can a CS student shift to data science without any major transformation?
I
I
would,
think we already covered that
yeah,
one.
and I would say I am myself an example of this case. So I am not a CS, but computer systems engineering. I was a CIS major, and then I moved to data science. And actually, I won't even say moving to data science. It's just like narrowing down of what you are already doing. Hmm.
Okay, so there is a very specific question, although,
Hmm.
which says explain about differences of R DBMS and RDBMS.
Mhm.
It is a little off track, but yeah, we can, I think,
I can
put the
give it a
question.
shot. So the difference is in R, and as you can imagine, R is basically standing for relational, which means that in the DBMS, database management system, there could be a structure of the data that you are feeding in, so or not. So if there is a structure, it's a relational database. So you can put everything in tables, for example, and then there is data coming in which cannot be put into tables because the structure of the data is not fixed. So in some cases, some parameters are there, some are not there, and you cannot put them in an Excel file or in a table or in SQL. So you would need solutions like NoSQL or some kind of JSON mechanism to open such databases. So that would be the basic difference. Structure versus no structure. RDBMS have a structure, and no RDBMS, they don't have a structure. Hmm.
Okay. There is another question of Tower. She says, what is the solution for big data?
What is the solution for big data? What is the
Yeah, I
problem
think
here? I didn't get the question.
exactly. Tower, I think you should rephrase your question.
Yeah.
Um, Okay, any better software to process the amount of data? What amount are you talking about, Sakib? Because she explained about big data as well as the smaller data. But
Hmm.
yes, I get what your question. Um,
Hmm.
mhm.
Typically a programming language, like, so if you want to store your data, so go for smaller data sets, you go for a solution like our DBMS, so Postgres or SQL database. But if you have huger amounts of data, then you go for data storage, you go for Kafka or Cassandra. And when you are going for processing, then you try to go for a language like Python. If you have time means processing time, and then you try to run them on parallel processing. So, for example, MapReduce is there for executing processing bigger amounts of data in parallel. Yep.
There is another question. I think some of the questions are from semester one or two students. It says which tool is better for Python? I guess there are a lot of, but we can put the question.
Hmm. Again, it depends on what do you want to do. If you want to, so is this in continuation? So Anaconda or PyCharm or other one? So
Yeah.
okay, Python is a programming language, Anaconda is a framework that allows you to install Python and its related libraries. Since you are, since you'll be working on projects which would depend on many third-party libraries, you won't be able to take care of all the dependencies and all the library maintenance and versioning and everything yourself, number one. And number two, if you are working on multiple projects at the same time and the two projects have two different set of requirements, some need some older version, some need a newer version, then managing everything separately at the same time on your machine needs a way to, and Anaconda is actually or is a way to provide that sandboxing for you. They are not an alternative to Python. They are ways for you to create your framework or environment so that Python can work properly on it. Okay.
Thank you. Question is answered. We have one more question
Mhm.
that says, what is the availability of window-based excellent software and tool which can deal with huge next-generation data available in the database and any online portal? Is there any? Also, tell about authenticity.
I am sorry, I'll have to skip this because I'm not a window expert here. So, um,
Okay.
yeah.
So we are
Uh,
talking about Linux-based system here that you.
Linux, yeah. So all what actually, we can have Python for Windows as well, but if you are asking
Yeah.
about exclusively Windows-based tool for next generation data, I would go for Python actually, if that answers your question. And even we have SQL for Windows as well, but I really haven't worked on Windows.
Okay. Someone asked,
Mhm.
what are the next big developmental steps in data science?
Next
I
big
think we have
development.
way to go. Yeah.
Mhm. We have a way to go. Yep.
Should I move forward?
Mhm. Yep, yep,
Yeah.
yep.
Okay.
We have a way to go. So
Yeah.
data science is not going anywhere. It will only increase because because everything is becoming a data point now. With everything being connected online, that data process from collection to storage to processing to
It's also
visualization to making decisions. It's all data
true.
science.
Okay. There's a question that says, is the R language an adequate substitute of Python when you start out as a data analyst or data scientist?
Scientist. Yes, but typically Python is considered easier and more strong compared to R. So yeah, we have yeah, until and unless you have a reason not to use Python, I don't see why you should just skip Python and go to R. Yeah, it's a matter of choice. I don't see any specific advantage of using R.
Okay. Another question is, data analysis can improve our statistical errors. Is this a true statement?
Mhm. Data analysis, yeah, data, not data. So part of data analysis. So
Yeah.
data. When you are cleaning up your data, you are doing
Pre-processing.
pre-processing.
Mm,
Exactly. So remember, we spoke about difference in units. So for example, you have difference centigrade and Fahrenheit all in one. Your error would come out maybe more, and when you clean it up, then your error would go down. And but I would say actually more than data analysis, data science would actually improve your statistical error.
we have another questions. A question that says a few words about Hadoop framework.
Hadoop framework. So Hadoop was actually proposed by Yahoo to process big data. So when it comes to big data processing, you need to remember we spoke about data engineering that you need to actually prepare your infrastructure. And then here comes Hadoop. It would allow you to store your data and process that. Just give me a second. I'll turn the right light on because it's too dark.
Meanwhile, Irfan, we have pretty much discussed this in the start. If you will listen this recording, probably you will get to know that we have already discussed data science versus machine learning versus data engineering quite in detail in the start.
Mm-hmm.
So it says, what is the importance of domain knowledge in data science project?
It simply makes things better. So imagine if I ask you to work, let's say you have studied computers, and if I ask you have nothing to do with medical science, and if I ask you to do something which about blood reports of some person, and of course a doctor would be having the presence of a doctor would actually make your life easier, because he would be able to just look at the data and say, okay, this blood value is, it seems totally off, etc. So domain knowledge just makes a difference, and actually this is one aspect where you can make a difference. So if you love certain domain, if you have knowledge of certain domain, and if you are not a computer science or a data science student, and if you want to switch into data science, then I would recommend, um, just a recommendation, not necessary, but you can actually take up data science into a domain with a company that's working on your domain of expertise. So we just spoke about biotech, from moving from biotech to data science. So if you want to move from biotech to data science, come to data science and work for a company that works with biotech. So you will bring biotech knowledge, and you will have data science expertise as well.
Okay, thank you so much. There's another question. I have a question that says, what is the relevance of data science in Lean Six Sigma and even in manufacturing startup?
What do you mean by manufacturing setups?
Maybe I think he was probably or she was probably trying to write startups. I just have an idea that maybe
Mhm.
it's startup or something like that. Or maybe manufacturing units, probably.
Mhm. I'll have to check. I have not worked on Lean Six Sigma either. So
All right.
I can relate data science with manufacturing setups for sure, which means that when you are or startup, for example, if you mean what what kind of data are we getting there, and what kind of how what we can do with that data, then it really depends on what kind of parameters you have which are necessary for manufacturing. And here by manufacturing I mean I am assuming some kind of civil and mechanical kind of manufacturing going on. So um, I hope this answers your question, that it really depends on what's the input and which phase you are talking about, because there can be the data coming because of the manufacturing parameters or the product or whatever is being constructed.
And we have almost our last question, which says, what kind of faculty I probably think is available in data science? I think you mean by faculty, you mean teaching faculty.
Maybe you can answer this question better, Mubashara.
I think they have it from everywhere. Even some business programs now include specializations in ERPs and machine learnings. Even
Mhm.
BS Information Technology, I've been looking for some programs, and they are there. So they obviously in Pakistan it's evolving right now when it comes to academia. But yes, it's there. It's not that it's completely out. It is there, but it is evolving, kind of similar, I guess, in the industry.
Mm-hmm, mm-hmm, mm-hmm. I hope that answers
Um,
the question.
yeah, I think
Mhm.
we don't have any more questions. Okay, okay. So there is a question that says, do econometrics model can be used in data science?
Definitely, definitely. Nothing to add. Like, yeah,
That
yeah,
can be used.
yeah.
Yes, Adarsh. Um, with this, I think thank you so much. It's this session went way longer than we anticipated, and participation of even the audience was really helpful in getting to know more from Dr. Um, thank you, really. Thank you so much. I mean,
Thanks so much.
it's really nice, Dr. Mehra, and it was very overwhelming. Even the session itself was very comprehensive, and when the questions came up, so it became very interactive and very nice.
Exactly.
And uh, I hope we'll be in touch with you. And we'll recommend even students. We'll be in collaborations, and we'll invite you sometime as well
Yeah,
again.
sure, sure. Most welcome. Nay, I really enjoyed talking to you, and the answers were the questions answer. Okay, the questions were like really very interesting. And if you have any more questions, just feel free to reach out, and I'll be very happy to help you further.
On behalf of IEEE Women Engineering Lahore section, on behalf of Let's Pep Talk, on behalf of all the participating units that we have, we thank you immensely and take our gratitude from us. And I think we'll be in touch with you. Thank you so much again. And
Thank you very much.
thank you for being a panelist and for being such a good explanator as well.
Thank you so
What
much.
should I say? I mean, it was really nice. It was really nice because people are coming so much. Some people are actually coming probably because of the buzzword. They are getting attracted to the field. But if they get the right information in right time, maybe they'll that will be helpful in getting somewhere on the right track.
That's
So
true. And yeah, I want to thank you and IEEE as well, like all of you, the WIE and all the organizers. You have been an awesome moderator as well, and thanks
thank
for
you.
supporting me all in all the answers. And yeah, this topic was really the need of the time. And yeah, some if we can share some knowledge with the younger generation at the right time. This is the time when they need to decide which career they need to take. If we can do anything to help them, that's awesome.
And it was very positive from you to say that at any point you can switch from anywhere to data science, and that
Exactly.
is that is I think hopeful for many people around it.
Exactly. I myself switched to data science after 12 years of graduation. So if
Yeah,
yeah, yeah. And yeah, 12 after 12 years moved here and been here for 7 years. So
yeah,
that's one more example.
yeah. Okay.
Yep. Thank
Thank
you
you.
very much, and thanks to everyone who was here for asking questions and for the appreciation. Thank you.
Welcome. Thank you so much.
Thanks.
Love.
Bye, Dafis.